Hello, everybody, and welcome to this week's Zoom. It's been quite a bit of time since we've done a Zoom, so we wanted to kind of give you guys a little bit of an update on where everything's at, how the Tritium Plus roadmap is going, and also kind of what to expect in the near future. So we're also going to be combining this one with a demonstration of the invoicing DApp. So we're going to kind of show you guys how that DApp works. Do a little bit of an invoice between all of us, and then you're also going to be able to utilize that situation to potentially see transparently these invoices. So we're going to be working with the block explorers to also help them kind of create more transparency. So as a community, you'll be able to see all of the money being invoiced in and out of the US Embassy, which is really cool. We think it's next step, and it automates our administration, which is great. So it's a forward step. We kind of back in June when I had to start kind of taking admin into my own hands, I was like, okay, well, let's automate this. And then we came up with this really cool concept of using smart contracts to create our invoice systems, which is using a decentralized exchange. So essentially what's happening is you're creating an asset, right, which is the invoice, and then you're putting that asset into a conditional contract, requesting the asset to be paid out at a certain amount. So it's basically like an asset sale, a decentralized asset sale that's happening with the invoicing module under the hood. So it kind of shows us also kind of what the DEX is going to feel like as that starts getting running under the hood and everything like that. So I guess a basic update from our side, we're focusing primarily on the mobile wallet. So the last few months, we've been doing a lot of maintenance on the public network. This last update, we just did a hard fork. So some of the changes that happened, there was a bug with the integer overflow in trust. So people that had a large amount of stake that unstaked actually would get unfairly penalized. So we created a trust consistency check that basically on your very first version 8 trust key, it would go through and it would check back all of your trust calculations in your sig chain. And it would confirm them against one using 128 bits. And if you found any differences and discrepancies, it would resolve that. So there was a couple people that had that bug. So that was the primary reason for this hard fork. The other reasons were the reallocation of the funding distribution based on the DAO vote that we did on December 12th, which is now 65% US, 35% Australia. So that kicked off very well. And then another one that we put in there was a unified time adjustment. So if all of you are aware, the unified clock was about 299 seconds fast, which means that, or we're about 299 seconds slow, sorry. So your times of your transactions would be slightly off from your actual computer's time. And that was just kind of part of the unified time being slightly off from the zero offset. So we ran through unified time adjustment, which went over the course of 2 days. That's successfully completed. So now the unified clock is 100% synchronized with conventional clocks, and they're all synchronized with themselves, which is really nice. So I also did a lot of bug fixing with the unified time as well to shore it up, to make it much stronger. That's part of what our most recent update 5.02 addressed. And then there was another bug that we've been chasing around for about 4 months, where your wallet would get stuck and you would have to restart it. That was a very, very difficult bug to find, but it so far has not come back since these most recent updates. So network stability looks much, much better. Under the hood, everything's going actually really well. I'm seeing an increase in transaction volume, increase in difficulties, increase in actually website traffic and interest, starting actually on the stock market crash on Friday. Even though crypto crashed, we saw a huge spike in interest. And interesting enough, I've had a lot of friends that didn't really take crypto too seriously before that are now calling and asking me if I can help them learn. So I think we're moving into definitely a time when crypto is going to really start to shine, because I think over the last 6 weeks, the Federal Reserve in America anyway has printed close to $7 trillion to pump it in the stock market. And that's 7 trillion with a T. I think our national debt before then was 7 trillion or 17 trillion, something like that. So that's almost 50% of our entire national debt. So that's not good. So I think that, from what I've observed, I've seen a lot of more people becoming more interested in crypto. So this is one reason that we put the mobile wallet as our highest priority right now. aside from the core maintenance, obviously, because if there's bugs that need to be fixed on the public network, there's bugs that need to be fixed. So the development progress as far as the mobile wallet, we just had a dev call yesterday. We're getting everybody mobilized on it this week as far as we developed this wallet in what's called React. And one of the reasons that we chose to use React is there's basically it runs in Electron, which is the web app that you're using. But on a mobile phone, there's this thing called React Native, which actually allows you to develop applications in React and use React Native to deploy them on mobile applications. So we basically designed everything to be very easy to shift over to mobile. So what we're doing right now is we're just figuring out our deployment, which is how are we going to package this daemon together in a decoupled manner into the wallet, and then we're assessing what packages are going to carry over into React Native from Electron. And then obviously we have to make some adjustments to the actual interface to be simple and smoother than the current interface. And then, what's it called? Brain fart. And then the final one is the light mode, which is the backend. So this is a full header verified light mode. So in conventional mobile wallets that you're using with Bitcoin or Ethereum, generally what they're doing is they're actually signing the transaction offline and then sending that through any type of public API. So your wallet, your mobile wallet, isn't really doing any verification of the data. It's pretty much just keeping your UTXO set. So our mobile wallet is actually going to have pretty close to the security of a full node, but only needing to keep a couple hundred megabytes of data. Because what we're doing is we're downloading the block headers, but we're not downloading the entire global state. So with these block headers, we use Merkle proofs in order to confirm the transactions actually existed in the blockchain without having to know every other single transaction. So this light mode is pretty much done. I've been coding most of it over the last few months. I'm kind of just plugging in right now and getting all of that debugged. So the mobile wallet's moving pretty well as far as, I'm concerned anyway. The more difficult code that needed to be done was the events and notification system in light mode on the back end, which is mostly done now. So we're really just looking at the difficulties with deployment as far as we have the decoupled daemon architecture. So we need to make sure we can package the daemon in with the React Native application. But the nice thing about it being React Native is React Native works on both iOS and both Android. So we can develop just one single mobile wallet, one single repository, and it should work on both of them. Is a nice equal deployment. So that's been moving along very nicely. Did I miss anything, Paul? You're muted. Okay. Miss anything?
Thank you for unmuting me. I think that was it. Yeah, I was hoping you'd describe a bit more about how the did we agree on light mode or client mode? I forget.
I think we said client mode because that's technically the, yeah, I mean, yeah, dive in a little bit more. That's cool.
Yeah, so, okay, so as Colin already described, the client mode means that you won't have to download an entire blockchain to your mobile device, only the block headers, so there's only a couple of hundred megabytes of data that's in there. In addition to that, the way it's going to work is your mobile device will need to also have your signature chain, which is a series of transactions that relate to your user, your chain. So what will happen when you first log in, you'll synchronize the network, you'll go to your device, you'll tap in your credentials. It's then going to contact one of your peer nodes to verify your credentials. It's not going to send those credentials out, but what it's going to do is use, actually we probably don't need to go into the authentication side of it right now, but it's going to authenticate you, and then it's going to return you your.
I'll go into that after because it's kind of interesting how the authentication system works on the Tritium protocol, and it's a step towards SafeNet. So I can dive into that after you finish.
Okay, that sounds good. Okay, so so then one of your peer nodes, you're then going to talk to one of your peers, and it's going to send you your list of transactions. So from then on, your local device knows your signature chain. Because it knows it has your entire signature chain, it also knows about what accounts you have and assets and all those sorts of things. And you can then proceed to create transactions. Your your local device, sorry, to begin with, our mobile wallet is probably only going to have some basic functionality, such as being able to send and receive. We are going to have it processing notifications. So if somebody were to send you some funds, then it'll be ticking along in the background and be able to pick that up and credit it to your account. So in terms of, yeah, that's where I was going with this. In terms of data, your mobile wallet's only going to need to know all the block headers, so a couple of 100 megabytes, and then your signature chain, which however many transactions you've ever made, but that's going to be relatively small. That's the only data it needs to know about. When you currently in the desktop client, when you want to do something such as send funds to somebody else, you either put in their account address, and we check that it's an address, so we have to check that the address you put in is valid and it's an account, and so on and so forth. We need to do that. Or you can put in the name of an account. As you all know, that's part of one of the features that we have in Nexus, is that you can name accounts. Now, this is where we're going to have to do things slightly differently on the mobile wallet. Excuse me. Because what we don't want to do is have your mobile wallet have to download the entire database of names that exist on the chain to be able to do a lookup. So we're going to implement this in a very similar fashion to how you how DNS works when you put in a web address at the moment. It's a very similar system. So what we'll do is, your mobile wallet, you got it up. Let's say you want to make a transfer to Paul. My account's called default, so you want to make a transfer to Paul default. What will then happen? Your mobile wallet will then contact one of a series of trusted nodes. To begin with, it'll just be the seed nodes, but we'll add the ability for other nodes to have elevated trust, and it will ask it, hey, what's the address that goes along with this name? Return it to you, and that's how that feature is going to work. So we're still going to be able to support named accounts and sending to named addresses through the mobile wallet, is what I was going to say. The other feature that we're going to get into the mobile wallet, I don't know if it'll be in the initial release, but we're working on it right this minute, is staking. Is that right, Colin? We're going to get that in early on.
Yeah, so the way that right now, it's going to have to be a form of pooled staking, because in order to do staking, I guess effectively what's going to happen is you're going to have to verify your transaction history. So you're going to have to run all of those contracts and sanitize them before you put them in. So in a light mode, you're not going to have that global state, right? Because we're trying to keep your disk space low. So what ends up happening in those circumstances is you, oh my gosh, brain fart again. You have, I don't know, my brain just shut off, man. Let me think.
It's one of those days.
I've been staying up like 5 a.m., man, and like the staying up late's just like starting to like get down on my memory. Anyway, so you have the light mode, header verified, blah, blah, blah. Yeah, so you don't have the full global state. So when you do the pool staking, you're basically going to have some sort of consensus algorithm associated with knowing what the transaction history is that you're verifying, because the way that the pool stake works is it's going to kind of be like an agreement protocol. So I'm going to put out a pool stake transaction, which is basically indicating other people that I want them to grab my pool stake. And there's going to be it's going to act like a pool where the actual block finder is going to receive a reward, a multiple 2% reward compared to, other people. So you're going to pay a little bit to do this pool stake, but every one of these transactions, before they create the pool stake, we're going to run it through a special algorithm that is essentially kind of like a filter, kind of like a Bloom filter, that's essentially filtering out the transactions that are in there. And we're putting that into a root proof, so that when you're pool staking on your mobile device, you'll be able to rely on some of the other nodes, right, that you're logged into, obviously, to be essentially managing the transaction or doing the transaction verification for you. And then other people aren't going to include your pool stake if you don't have the same transaction history as them. So you still get the security of it, but then you get the ability to stake on your mobile device, right? Which is really cool. And the pool of stake protocol actually is going to make the proof of stake process much more secure, because right now it's basically one winner is the one that publishes the transaction history for that block. But in a pool stake, it's going to require everybody that's pool staking to actually have the same proof and be processing the same set of transactions, so that somebody can't just try to pool stake on your behalf and use that. Kind of like the way mining pools work right now is you're basically putting your hash power to their wallet, and they can do whatever they want with their wallet. They can choose whatever transactions they want to verify. They have absolute control over that. But in this sense, you're actually publishing the proof of the transactions that you want to verify. So you're actually acting kind of as a proof that happens before the actual block proof, so that in order for it to verify, all these pool stake transactions have to have the same transaction history. They have to be verifying the same transaction history, which makes it much more secure, because then it's less based on one actor and it's based on multiple actors. And so this segues a little bit into the authentication system, where essentially in the Tritium protocol right now, you have what's called a crypto object register. So this crypto object register is just a series of hashes of public keys, and you're using these public keys for different aspects. The one aspect that we're using the network key for is you actually sign a message from that private key that you've generated deterministically from your SigChain credentials. And any remote node basically takes that public key, hashes it to the crypto object register, and checks that entry to make sure that it's a valid public key. So what this allows us to do is it allows us to do kind of off-chain signing, but it's still tied to your signature chain. So over the Tritium protocol, when you're in light mode, what you're going to actually have to do is you're going to have to log in to the network protocol. So you're actually sending this public key and this digital signature that correlates to your crypto object register, so that the recipient can then verify, okay, I am talking to this actual person. Now, this is a big step towards SafeNet, because what it's allowing us to do is it's allowing us to bind a specific address or a specific socket connection with a specific individual in the network, which is really important, because that's when we can start to use this trusted elevated layer of the network, which we call the trust network or trust nodes right now, right? And you can verify, okay, well, this person logged in, I can read their crypto object register, but I can also read their trust object register and verify the amount of trust they have and how long they've been around on the network, right? And this is how unified time is progressing as well, because right now unified time relies mainly on the DNS seed nodes. So it's still decentralized, because anyone's able to add a time seed to the DNS seeds, but it's not as decentralized as it could be. So what we're progressing forward with unified time is you're going to start actually grabbing samples from trust nodes. So if you're connected to a node and they're logged in from a trust key, then you'll accept time samples from them, so that the trust network will start to become more of that publicly accessible network, that elevated level of trust. And you're doing that through this type of network authentication, which is kind of a very rudimentary form of Lisp, because what you're doing is you have a static identifier, which is your Genesis ID, which is kind of like an EID, but it's just not happening all on the network layer like Lisp is. And then you have your IP address or your session IP address associated with that particular socket session. And that specific address and that specific session then gets bound, so then you cryptographically have proof of who you're talking to. So that allows us to start kind of adding all these different higher level accesses.
Yep, that's it.
Yep.
I hope it was clear from what you said, but this crypto object register is something that is created on your behalf when you first generate your signature chain. If anyone's ever looked at a Genesis transaction, there's a few things that we create on your behalf. We create you a default account, a trust account, and a crypto object register, and then we generate keys for you, initially, and they kind of, and the public keys are stuffed in that register.
Keys too are really important too, because your crypto object register has your main like core keys, right? Your Lisp key, your network key, your auth key, your sign key, your verify key, which these are good for like if you're signing a document. If you want to prove that you signed a document, but you don't want to actually store the signature on the blockchain, you can just store the digital signature with the document using your signing key. But another really cool thing is, since this crypto object register is a bunch of cryptographic keys that are generated from the entropy of your SigChain, that means you have portable encryption system wherever you go with your SigChain. So one of these keys can actually be a symmetric key, right? That you can actually use in order to generate and encrypt data, right? If you want to have like symmetric encryption on data, or you can use, somebody else can use your public key to encrypt to you as well. So that kind of sets also a foundation for the LOD file system when we start having more of this authentication going on through the public keys. And then that's also how you verify that you are you in a public setting, instead of having, like, if I want to verify my SigChain to somebody else on another mobile phone, I'm not going to be generating a transaction because that's just going to load the network down unnecessarily. You're just going to be generating a digital signature or a proof from one of the keys in your crypto object register that the other person can scan via a QR code to verify, okay, well, you are the actual owner of this SIG chain. So it creates kind of a verification system.
Yeah, cool. Okay.
And I think we covered light mode. The light mode's going to rely first on resolving, because you're not going to have the full global state, so you're going to need to resolve names, kind of like DNS, through publicly accessible nodes. So we have some public accessible API nodes right now that it's going to kind of piggyback on that for the first until we add code basically to where if you need any entry, any registered state, then you're going to actually download the transaction and Merkle proof of when its last state was changed, so that when light mode is fully complete, it's going to have essentially the security of a full blockchain node without needing to have the full state. Now, this is also going to be something before the mobile wallet comes out. When client mode is fully tested and running, you'll be able to run client mode on your desktop wallet too, which if you want to just run, if you don't stake and you just send and receive Nexus, then you can just run a light mode and you'll save a lot of disk space and your wallet will be much faster. So that's kind of like a kill two birds with one stone. You get kind of that benefit of it that way for desktop and for mobile. So,
yep. Yeah, so pooled staking is something that will go into the mobile wallet, but it is being worked on now. And the same as Colin just said, the same with the client mode. These are things that we need for the mobile wallet, but are also going to go into the desktop wallet as well. They will be useful regardless of whether we get the mobile wallet out. So all these things are running in parallel. So I think that's kind of it. I mean, as Colin said, at the start of this call, we're making sure that we're concentrating on tasks that benefit the mobile wallet development right now. So, for example, I've changed on the API side of things. I've changed track now to get the API ready for client mode. There's certain parts of validation of user data and stuff that we can't do in light mode, and I just need to shore up the API to handle that. So yeah, I think that's everyone's kind of now concentrating on the tasks that are required, the steps that are required for the mobile wallet development.
Yep, that's our most important one. So we think that's something that's going to really help a lot of people. I mean, if you say, "Oh, hey, yeah, you got my Nexus," wait till I get home, I'll go send you some Nexus. It just we need a mobile wallet. So I mean, it's proper timing now too, because building a mobile wallet a couple years ago would have been a waste of time because it wouldn't be backwards compatible with everything we're doing. We would have been wasting our time building something that the system wasn't necessarily ready for. So now the back end and everything is just running like a fine old machine. So everything's good there. So we can really start diving into that. Now, I think I can briefly touch too. So when everything went down last week, right, the other week, and there's fear everywhere and everyone's like, oh my God, the world's ending, right? And I was just like, what am I going to do with my time, right? I could sit here and I could worry, or I'm like, you know what? I'm going to see what Tritium can do. So I took it to load testing, right? And I did remote tests, local tests, whatever else. I mean, with remote tests, I ran out of bandwidth. I ran out of bandwidth in about 4,000, 5,000 transactions a second or contracts a second. But local tests, I did push it as high as I could to just kind of see what it could process, right? What are some of its peak capacities it could process? And locally, it processed 12,000 contracts a second, like nothing. I mean, that particular block had about 85,000 contracts in it, and it processed just the same. Very, very quick. I did a lot of optimizations as well. And I'm kind of transitioning that into kind of a full public load test because I want to get more public participation, because my biggest limitation on my load test is I ran out of generating capacity. I can only generate transactions so many per second on my physical computer. I'm bound by its capability because the Argon 2 and all of the other computationally intensive stuff that it takes to generate. So the way I got it up to 12,000 contracts per second was doing 500 contracts per transaction, because I wanted to test. Now, each one of those transactions was pretty heavy duty. I mean, I was pushing at 12,000 contracts a second. I was pushing 20 megabytes a second of data through the chain. So if you just imagine when you're at 12,000 contracts per second capacity, I mean, you're going to need at least, or sorry, not 20 megabytes a second, 5 megabytes a second. You're going to need a seriously fast internet connection to get up to those types of speeds. So it was a good test, because I wanted to make sure that our processing far exceeded our actual hardware limitations, because, you know, we could max out our bandwidth and then max out our CPU right at the same time, and then that's not going to be very great. You know, then you're pretty much going to be stuck at your bandwidth limitation. But now we're pretty much limited by the bandwidth, and the processing under the hood is actually much, much faster than the bandwidth is capable of, right? So that means as we get more bandwidth, we're going to increase our capacity, because the processing of it was significant. So I ran tests for a few days, and I ranged anywhere from like 2,000 to 3,000 contracts a second. It was just like nothing, dude. I mean, it was just chugging away. Like, I think it was processing blocks in like 50 or 60 milliseconds. So, you know, syncing those types of blocks would be a lot slower, because you just got massive amounts of data. So, I mean, these capacities are really impractical for a single dimensional blockchain. I wanted to do them not to necessarily say, oh, Nexus does 12,000 contracts per second, but I wanted to see what our underlying processing capacity is under the hood, because this is what's going to determine our capacity of each L1 state channel, right? And we're going to be having to set with Amin the maximum capacity, the maximum throughput of each state channel, the data rate. Because only way to really overcome this bandwidth and disk limitation, right, is you have to have that sharding. You have to have these multiple parallel channels that are doing most of the heavy lifting in these shards, right? So it was very successful results. I was, to be completely honest, I was frankly very surprised. I didn't think we'd get past 10K. I just haven't seen any blockchain be able to get past like 1K. And even if they shard, like if you see like not eMuni, they're Radix, right? They, you know, claim they did 1 million transactions a second. Well, yeah, because they did 1,000 transactions per second on 1,000 nodes, right? Of course, that's, you know, that's going to make it seem, because they had like a single node shard, right? So that, how should I say, our baseline capacity for a single dimensional blockchain is pretty substantial, which is good, because that's just going to make sharding multiply it even more, right? And that means we can also support, you know, running on more consumer grade hardware for L1s, right? Like my OS X laptop processes 5 to 10,000 contracts per second, where my, you know, fast desktop does 40 to 80,000, right? So it's quite a big drop, but 5,000 to 10,000, I mean, this laptop could still keep up, you know, with that types of capacity. So I'm assuming we're probably going to see our state channel capacity like 1,000 transaction per second normal, and then 5,000 peak, 5 to 10,000 peak, I would say, capacity for each one of these. And I guess this can segue a little bit in to explain some of these L1 shards a little bit more clearly, because I came up with a really nice analogy, I think, that will help people understand how these shards work. Each one of these shards, think of them as like a private club, right? It's a private building, it's an enclosed building, and you got bouncers, right? You got security people that are basically regulating who comes in and who goes out, right? They want to make sure somebody's not bringing a drink out or whatever else. So these security guys are like the validators, and the people in the club are like you're just normal people that are having the transactions processed. So in order to get into the shard, you have to sign into the club, right? You have to sign in and say, okay, I am signing my SIG chain to this shard. So it becomes kind of a process where you have, you know, legacy mode and Tritium mode. With Amin, you're going to have Amin mode, where, you know, you transfer from Tritium mode and you say, I'm going to lock my SIG chain in shard 1, right? Because I like those people there. And I'm going to ask shard 1, hey, will you take me? They'll say, sure. The security guys let you in. And then you therefore start validating completely in that shard. Now, if you decide that you want to move out of Amin mode, then you just say, okay, I'm leaving the club. You go to the bouncer, you sign out, right? And then you leave the room, you leave the shard. And then that takes you back to Tritium mode, which will just be processing like a normal blockchain, right? So Amin's going to give people the opportunity to use this new type of shard architecture, but not use it if they don't want to, right? We want to make it kind of voluntary as much as possible. The only time that's not going to be voluntary is when we get to Obsidian, when we're going to have to kind of force every, you know, UTXO and Tritium mode are going to just have to dissolve, and everything's going to go into pure Amin Obsidian mode. But anyway, now for validators, right? If I want to become a validator, now I have to go to the club and I have to talk to the security guys, right? And the security guys have to agree that they want another validator in, and they want me. specifically. So I have to actually sign up to become a validator and then be approved by these validators. Now, if there's discrepancies or there's issues with these validators being able to come to consensus, that's where the L2 layer comes in. And that'll say, okay, well, this guy wants to be in, you guys are split 50-50, we'll be the tiebreaker and we'll let this guy in. So you create this type of kind of private area, right, where each one of these shards is its own room where nothing goes between them, right? So somebody doesn't just go and leave their shard and then, go jump in another shard immediately, right? It's a bit of a process to do so, right? So it makes it kind of more, you get a lot of the security because you have this type of reputation-based, invitation-only type validation system that makes it a lot more difficult for, just newcomers to come in and try to just make the consensus. And it also is something that you can't just come in, you have to get approved to come in, right? And then as the regular user, you essentially are locking yourself in that, in that room if you want to be processed in that shard. So you're kind of like opting in. So that means at any point in time, like the total number of validators and the total number of people being processed are always known by these shards. So yeah, I hope that helps kind of explain it a little bit better in kind of how Amin's going to work. Now, each one of these shards are going to be, there's going to start with four L1 state channels. So you're going to have one of four options to go in. But then once the capacity gets large enough, right? Like once we start reaching peak capacity, 1,000 to 5,000 transactions per second on each one of these, the 3DC goes through a mitosis process. So mitosis is what happens when cells divide into two. Think one of these state channels is it's like its own cell. It's got its own, self-contained. It's, it operates itself. It's got its own validators, everything. Now the cell can actually go through mitosis, and this state channel can be split into two, right? And so all four of these state channels then become 8 state channels when it goes through a mitosis period, which is going to increase the overall capacity of the network. And that's where you get this type of fluid scalability where the structure itself can accommodate the difference in size, right? When you have a higher transaction throughput, you're going to just need to have more of these shards because, like I said, you have bandwidth limitations and you have disk limitations. And those are our two pretty much inhibitors right now that slow everything down. So the only way you can essentially amplify that or multiply that is through parallelizing it.
Just something I wanted to make perfectly clear on that is that each one of these state channels are not completely independent in such a like Lightning Network or anything like that. Okay, so each one of these state channels will be processing transactions in parallel. So let's say a new transaction comes onto the network, it's going to go into one of these state channels in a deterministic fashion, which means that we can tell from the transaction as it comes in which one it's meant to go to. And so all the transactions coming into the network then get filtered off into one of those, well, initially 4 state channels for processing. And then every few seconds, I think we're looking at about 5 seconds, each one of those 4 state channels will package up all of the transactions that it's currently processed and put it into a state block. And so these are like mini blocks. That's probably the best way to describe it. And Colin, stop me if I'm wrong on any of this because it's been a while since we talked about it.
No, you're doing excellent. It's good. It's good to hear other people explain it. Keep rocking.
So we've got each of these nightclubs, whatever you want to call them, each of these 4 state channels. They're all processing transactions in parallel, and then every 5 seconds they package up what they've got, put them into a state block, and then we take the hash of that state block, and those go into a regular block. So what that means is, and as those 4
hash of the crosslinks, so every time you got your L1 state blocks, and those are chained like a linear blockchain, and then you have kind of like checkpoints, which are lateral checkpoints, and those are your cross links, where it's kind of like the L2 layer saying, okay, this is a checkpoint between all of your shards. This is a point in which I'm synchronizing, and that's why it's called multi-dimensional chaining, because we're chaining state blocks this way, and we're chaining them this way as well. So this state block at a binding point, he's going to chain to this one, he's going to chain to this one, and he's going to chain to this one, he's going to chain to this one. And so what ends up happening is this L1 layer being chained both ways, right, now has immutability between the state channels as well as immutability forward. So it kind of forms like a lattice structure. Kind of think of it as like a crystalline lattice, kind of like how molecular bonds form. That's the best way to like, it's kind of like a crystalline structure is, and each molecular bond is like a chain link, right? And so we're, in a way, it's kind of mimicking that, but yeah, so just, you got the 3 state blocks, and then you have the horizontal cross links, which then that aggregated hash is what's passed up to the L3.
Yep.
Keep
And
going.
then, no, that's fine. And then, yeah, so eventually, we resolve all the conflicts between each of the state blocks, and then they get packaged into a regular block. So that's why all of this, it's what's different to say Lightning Network is Lightning Network or any of these layer 2 solutions are a bunch of people go into their nightclub and they close the doors, and they can just carry on transacting for any length of time, and only when they decide that they need to send somebody out to go and talk to the rest of the network, they can do that. And then they kind of reconcile back to the rest of the network. But that kind of Lightning Network, those side chains can be going on for any length of time, and there's no transparency outwardly to know what's going on.
And they're not
that's
linked.
where,
Yeah, they're not linked into the main chain, right? So, I mean, the problem with the Lightning Network is not necessarily like that it's layer 2. I know there's a lot of criticism about that, but the criticism is that the economics of it are just going to end up in a centralized topology, because if I need to send money to Paul, right, and me and Paul have a Lightning channel open, and we got half a Bitcoin in this channel, right? But no, let's say I need to send Paul's wife 1 Bitcoin, but I can't send it through Paul because me and Paul only have half a Bitcoin open, right? But the pizza shop that, me and Paul's wife like to go to, she goes and she, has a channel open there, and I have a channel open there. So they have, 5 Bitcoins open with her and 3 Bitcoins open with me. So I can send the Bitcoin through that Lightning hub, right, to then route out to her. So what ends up happening is you get these liquidity providers, right? You need liquidity in order to have connection, right? So in order to have connection, or in order to have decentralization, you need to have the connection, right? People have to have open channels with one another. Otherwise, it's just, I'm going to have to go through one. So what's going to end up happening, though, is nobody's going to have enough money open up in channels to maintain connections with one another. So these liquidity providers are going to end up opening up, because especially when Lightning channels become really expensive to open up, you're going to only be able to open up one. So then the pizza shop just continues opening more and more channels. They start charging fees. They start doing KYC. And then we start getting something that looks really similar to the banking system, don't we? Right? Because essentially you're depositing money into a Lightning channel to send back and forth with the user. I'm depositing a Bitcoin into a checking account with Paul so that we can send it back and forth to one another and then finally settle that balance on the main chain, right? So the problem is that the design of it, the architecture of it, the economics of it, the way these connections are going to form is just going to end up creating these massive liquidity providers, because not everybody's going to be able to have Lightning channels open up with one another, especially since the transaction fees is a huge drive of why people are saying you should use Lightning, right? So it costs a fee to open up a Lightning channel. And this is one of the reasons that we've kind of strayed away from this off-chain scaling layer 2 type scaling solutions like they have, because we believe that you can actually scale the blockchain in a way that's not necessarily just a single dimensional blockchain. We need to have multiple dimensions in order for this thing to scale and remain decentralized, because everybody basically is validating a smaller subset of this entire piece, right? Which, and then using proof so that you can verify that somebody else did actually do their work without having to actually know all of the data of their work, right? So you get this much more efficient system in this way, because you're not having to basically shoehorn this big giant freight truck, right? Like, which is like a Bitcoin block. It's just this big freight truck. And you're taking this truck and you're driving it to every city in the entire, world, and then unpacking the same copy of boxes, right, to every different person. But with this, it's kind of like a mail truck, where it's just one by one, you send your mail in, and then it gets distributed out to where it needs to go, rather than just needing to be flooded out everywhere. And that's the point of these shards, is these shards are kind of small, isolated areas in which you can have this processing be happening. But these L1 shards don't have the end all be all, because if there's a conflict inside the shard, that's going to create a fork, right? This is going to be a forked state chain, right? Or a forked state channel, which, this side is saying this and this side is saying this. That's where it gets elevated to the L2 layer. And the L2 layer says, okay, what is the most valid one of these transaction histories? And it resolves these conflicts. So it's kind of like a multi-step checking and balancing system, so that you don't rely on just one set of validators. And that's kind of part of our algorithms with the multiple mining channels and everything else like that. And that kind of ties together with this multidimensional chaining architecture.
Cool.
Cool. Yeah, that's good. I wanted to share that analogy. Make sure to send me a private message if you guys have any questions. We're happy to answer those as well. But I think this is probably a good moment. Paul, do you want to do some?
Yeah, I lost you then. You broke up. What did you say?
Want to do invoice?
Yeah, we can do. Do you want to show it, or do you want me to show it and try to send something to you?
Oh, you do it, man. You do the honors.
Shame Kendall's not here. He's
Kendall's birthday, so make sure everybody give Kendall a really happy birthday in Slack.
Yeah.
Yeah, it's his birthday. Like nowhere open. So.
All right, let me just try and share the right screen, and I can show you what's going on. Oh, I need to know what your either your.
Just send it to the US. Just send it to the US.
Okay. All right. Hopefully you can see my wallet.
Yep.
Good. This is just a test account that I use, but this is on mainnet. So you can see here I've got two accounts, one called default, one called savings, and currently it's got nothing in. So if any of you are not aware of how you load in modules, you go into your settings, into the modules tab here, and you can either drag and drop the zip file, the archive file straight into here, or you can browse to it. I've already dragged the Nexus invoice system in. I think that we've already posted the links to where the invoice module is on GitHub. But yeah, you basically browse to GitHub, download the zip file locally, and then drag it in here. And once it's in and enabled, down the bottom, I have a new icon called Nexus Invoice System. And I have not used this yet on this signature chain, so I don't have any invoices. But I'm going to create one for you. Excuse me. All right, so let's go through it and create a new invoice. What does an invoice look like? Well, we've built this DAP just to represent a fairly rudimentary invoice. It's got a few fields that you would expect to see in an invoice. A description, some kind of reference, which you might use for a purchase order number or something like that. An internal invoice number, you can set that to whatever you want. A due date, you can set that as well. The key pieces of information that you need to put in here, though, for an invoice to be valid are account payable. So this would be for me to choose an account that I want to be paid to, and a recipient, which is who I'm going to send this invoice to. And then underneath that, some invoice items. What am I invoicing for, and what is the cost? So let me just do one here, and I don't know. I'm going to invoice Colin for a cup of coffee or something. I don't know. Expenses. Let's do expenses. So let's do expenses. I don't need to put in a reference, so I won't. But let's, for my own benefit, put in EXP123. Don't need to do an invoice number. When's it due? Well, let's say it's due in a week's time. Okay, so 2nd of April. Account payable. I'm going to choose savings. Now, something that's quite cool with this whole invoice module is you can issue an invoice in any token you want. It doesn't have to be Nexus. So if I had my own token here, or somebody else's token, and I had an account for that token, I can choose that, choose an account based on that token. So I could be paid in whatever spade coins or something that he created. But I'm going to choose savings, which is a Nexus account, so I need to be paid in Nexus. Sender details. Well, I don't need to put this in, but let's just call this Paul so that he knows who it's coming from. Recipient. Here I could choose. I think if I have my things in my address book, I can use that there. But let's send this to US, wasn't it, Colin?
Yeah, send it to US.
Fine. Okay, so I can send that straight to US. And we can either put his Genesis ID, or I'm just going to put the name in. And just for everyone's benefit, I'm going to do recipient details as well. and add an item, and I'm going to call that coffee, and the unit cost is going to be, let's call that about 20 Nexus. Yeah, you owe me 20 Nexus. Maybe you've got 20 Nexus in there.
Yeah, I do.
And, let me just make my wallet slightly bigger here. Yeah, you can save this as a draft at this point, which is just a local thing on this particular client. It doesn't, that the draft doesn't go on the network, and you can open up drafts and submit them later on. I haven't tried that feature myself yet, but I know it's there and it works. So let's just do it anyway and send it. So I've got one coffee. Hey, let's do, okay, we'll just do one unit, and I can keep on adding items under here if I so wish. But let me just submit this and send it on to Colin. Okay, so this is a feature that we have added for all dApps, that if they require sending of a transaction, it will it will request the main wallet to enter your PIN. So what this means is you can be sure that a third-party dApp is not trying to steal your PIN, and the reason that you know that is that the feature will tell you what transaction it is trying to send. In this case, it's doing an invoice, create invoice. Perhaps we should pretty this up. I'll tell Kendall about that. So maybe we can just put this under details or something. So it asks for your PIN, and you can see what details that it need are going in somewhere else. Right, let me just put in my PIN and confirm that. And hopefully everything's working. I'll bet you on account. Okay, what did I do? Interesting. Did I pick the wrong account? No,
Should work fine. Yeah.
Yeah. Mine sync. Ah, good. Right.
Nice.
Done. Okay, so this cost me one Nexus, I should add. This cost me one Nexus to send. Invoices do cost you one Nexus. That's based on our data fee, and the reason that it costs one Nexus is this invoice is created in a register on chain. It's just a regular register, and that invoice data is stored in it. So that's our standard fee. So as you can see now, I've got an outstanding invoice. I can click on it and open it back up and see what I sent. I can, because it hasn't yet been paid, cancel it. What's happened behind
you can cancel it?
Okay. Yeah, you can cancel it. So
what pay it?
Pardon?
I guess you can cancel it. Yeah.
Yeah, no, I'm not going to cancel it. I want you to pay it, but I'm just going to explain what's actually happening behind the scenes here. So, I've created this invoice, and this invoice is a register, but think of it like an asset, right? Because it uses the same kind of system. It's a register that's on chain. And what I've done is I have behind the scenes, I've created this invoice. I've transferred it to the US Embassy. So I've made a transfer. I'm going to send to them, and they have to claim it, just as if you were transferring an asset between SIG chains. But I've added a conditional contract onto that transfer that says that Colin cannot claim it and take ownership of that invoice until my nominated account has received the required funds of 20 Nexus. So I've put a condition on it, and this is just how a DEX works. So it's out there. The transfer is on chain. That transfer is going to pop up in his notifications, or in this case, it's going to pop up in his invoices list to show that it's unpaid. But he can't. Oh, you've already paid it, haven't you?
Yeah, just paid it. Sorry,
paid it already. I messed up. No, don't do that. And it's refreshed to show it's paid now. So yeah. So I could, if I want to, cancel that invoice before it was paid, and claim it back to myself if I'd sent it in error or something like that. But as soon as it's paid, it's paid. So at this stage, Colin's now paid it. He's gone into his invoice list and seen one in here is outstanding. He's clicked on it and hit pay, put in his PIN number, and he's chosen which account he wanted to pay from, and then that's made the payment to me, and at the same time it's transferred ownership to him. So right now, if I have a look at this invoice, yeah, I sent it to his SigChain, which was A1B, blah, 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 but it's now being paid. And if we were to view this register on chain, and I think you can do this through the CLI using the invoices API, what you would see, and so if you were to retrieve this invoice via the command line, you would see that the owner is now Colin, which is this recipient SigChain. So I can do nothing more with it. I have a record that I sent it, but it's done. It's owned by him. So that's our proof that that invoice was created on chain and has been paid. And right now, you can only use the invoice module to see invoices that you've created, or sorry, you've sent or you've received. But in future, we might add the ability to view other invoices through this module to be able to give you visibility into other people's invoices that are happening. So that kind of transparency. And I'll give you an example of what I mean in just a minute. Anyway, so here we go, 20 Nexus paid. And if I go to my my history in my default account, sorry, this is going to be a bit slow on my machine because I'm running it in debug mode. Hey, here you go. I've got a credit of 20 Nexus. Perfect. That is how our invoice module works. So let me give you an example of how we can use this to show some transparency. I mean, Colin's already said that he's using this in the US Embassy right now for all the developers there every week, 2 weeks, whenever they're paid, because the contractors, whatever their contract is, the contractors send in an invoice and he can pay them through this system, and those invoices are on chain. So there's public transparency into what those invoices look like. And if you were to give me the address of one of those invoices, or do you want me to do the one that we did?
Bring one up, yeah, if you want.
I'm just looking for the one that we did recently.
Oh yeah, for the UK.
Yeah. I just need to find the. I think it's that one. No, just a minute. Won't be a moment. I'm just looking for the invoice. Yes, it is. Okay, so Colin and I did a test of this right after the recent activation, because the old UK SigChain still had some funds in it that had been building up, and those funds needed to be split between the US and an AU SigChain. So we thought we would do that transaction via an invoice. So there's some transparency of it. So if I use the CLI here and use the invoices API to retrieve that invoice, can't type. It's that one. Okay, yeah, cool. So invoices API. So I created an invoice and sent it to the UK SigChain with some details in it of what it was. And it was for 15,145 Nexus. And I added a description of what that was, and it was 56% of what was left in that SigChain. And that is on chain. Anybody can see that transaction. They could verify that the recipient was the UK SigChain. These are publicly known SigChains anyway. And you can check the account, which was the that is the default account of the AU sig chain, so you can see that as well. Again, this is all publicly available information. These sig chains are hard coded in the code. Or, you know, I believe they're the Block Explorer also shows them. So so you know that these are the embassy embassy sig chain and embassy addresses. And there you go. You have transparency of that transaction, so everyone can see that 15,145 Nexus was sent from the UK sig chain to the AU.
And anybody too that's contracting or freelancing in crypto too, and you're using the Nexus wallet, you're able to use this invoicing module for that as well. So we're not only just using it for the transparency in our US, but you know, it kind of came to me when I was using the wallet, and I just was realizing, wow, this wallet is powerful. It has all these different things that I need in it, right? What are some other things that I would need, you know, for operating a business that would be useful? And I was like, invoices. So that's kind of where this was born. And yeah, we pay every 28 days. We paid out last Friday. So if you guys, we'll probably be working with Cypherus to be getting these invoices publicly available in Block Explorers so that anyone will be able to see basically what contractors are billing out to the US Embassy in kind of an attempt. Anything that's going out of the US Embassy sig chain now, I'm requiring invoices. So that includes like marketing or, you know, contractors being paid or things like that, so that you guys will be able to, in real time, watch exactly how funds are being spent on the US Embassy to create stronger levels of transparency. So we're really excited about that. And it also automates a lot of administration work that I have to do too. So that means more time to code. So it's good.
So this this invoices DApp was built to, yes, we wanted to use it internally to get some transparency, but it's also a good example of how you can build DApp on Nexus and store data on chain. We built a new API to support this, the invoices API, but DApp, you know, and DApp developers would most likely either use our existing APIs, or they would you know, extend the API themselves. They could fork our code and create their own API for that purpose. But the invoices API in particular, we wanted to make this, even though we've built a DApp and have built the GUI here that that fulfills our needs right now, we wanted to make this invoices API extensible so that other DApp developers in future could add to the functionality of this for their own purposes. So for example, they might fork off the invoices module and decide that they want to add some new features in here, some new fields in here, or they might have a completely different desktop client or mobile client that for their own invoicing system that is going to use different fields that are in here. So what we did was, when we built the invoices API, we did it in such a way that there are a handful of mandatory fields, and I'm just going to flip back to the CLI here to show you what the mandatory ones are, which is the account, recipient, and the items. And within items, the mandatory fields are units and unit amount. But anything else that a developer wants to put into an invoice, they can choose to, and we just store it on chain as is, and without any validation. So for example, Kendall decided, not me as the API developer, there's no requirement for this, but Kendall decided that we want to add a description field. And he decided we want to put some sender detail and recipient detail and item description. And I'm just going to flick back here, and things such as invoice number, or you might, another developer might want to put in things such as payment terms. You know, that you're on a, I forget what you call it over there, but in the US, but you can say that you're on a you know, a 30-day payment term or 60-day or things like that. They could add these things in and just add them as fields into the API request that creates an invoice, and we will just store those on chain in a serialized JSON blob as is. So this gives full extensibility to developers to add whatever features and fields they want to into an invoice, as long as they adhere to using the mandatory fields, of which there's only a handful. So it's very cool in that respect. And that's kind of it. The module is completely self-contained. So it's a DApp that can be added to our wallet, but other than having to talk to the rest of the wallet in order to issue a transaction and ask for the PIN, the rest of this invoice module is self-contained, and that's exactly what we wanted the modules to be. It's not something, people can add their own modules, as you already know.
Yep.
Is there anything else I need to say about the invoice system? I hope that kind of gives a clear idea of what we've built and why we built it.
The only thing is that, we would definitely like your guys' feedback on it. We were considering changing the name module to DApp, since it's a little bit more understandable to people, because basically it is a DApp that's running in. This particular invoice module is actually a DApp, whether even it's a small DApp. So we're thinking of just any module that you put in is going to basically be a DApp. And then we're working on a directory as well, because we know the installation process isn't the smoothest, because you have to have, a list. So we're going to work on a directory list that'll actually be modifiable through a GitHub repository. So people, to add their module into the directory list, will just submit a pull request to the public repository. So if you guys have any feedback on that, if you like the name module versus DApp, we're considering moving to the word DApp in the next update or two, unless anybody opposes.
Colin, I can't seem to stop my screen share again. Would you mind turning that off?
Yeah.
Thanks.
You're welcome.
Wait, let me stop it.
Yeah, I think that pretty much covers everything.
I have some questions.
We got questions?
I've got some questions from Telegram for us.
Yep.
Just having a look. Progress of mobile wallet desktop light mode. Well, we've already covered that. We started that at the start. Any more new use cases in the pipeline?
Yeah, there are. We're not talking about them right now, but we've had some pretty decent progress with some other different use cases. Right now, I think there's a couple of them that we're working on in different industries with some pretty cool groups of people. So yeah, use cases are continuing to be driving forward. I think, we're focusing on kind of the more nonprofit, but there are some other ones that we're focusing on that are more in the for-profit area. And yeah, that's basically all I really feel comfortable talking about right now, but we are continually having use cases. There's been some people after the UK kind of went away that have taken it into their hands to start driving a lot of business development forward. So that's really cool. Exchanges as well. We're in contact with a couple new exchanges as well to be focusing on getting new listings and things such as that.
Is the team being contacted by developers wanting to build on Nexus, and can you give a rough estimate of how many? Well, yeah,
we are. I don't know. Do you want to answer that one, Paul?
Yeah, I was just going to say that from my personal experience, I'm getting contacted quite often, especially on Telegram, but also through the website, which the website chat we have now using Talk, answer quite a lot of questions there. People asking about how about how to build on top of Nexus, and I point them towards our API. Yes, we're getting contacted. Can I give you a rough estimate of how many? It's kind of difficult, but I've probably spoken to maybe 5 or more in this week. So there's a good amount. I think those are kind of more initial inquiries, though. The ones that are we're talking to more openly are the use cases that we're already working with people like Kool-Aid. So I talk to their developers once a week. In fact, I'm going to go and talk to those guys right after this call, and to help them. So yes, we are being contacted by new people and talking to ones that we're already working with. So that answers that. What are your thoughts on the recent events? Nexus price due to COVID-19, and how does it affect the team's progress on development? Great question, and one that we were going to talk about slightly today. I think Colin already has talked about this in Slack earlier in the week. I don't think we can really talk about price. It's not. Well, I'm not we don't know to talk about market conditions other than the fact that yes, the entire market has been affected recently. It seems to be bouncing back a little bit right now. In terms of what that means for us, it's as ever, our funds are tight, but we're still managing to continue development. Is it affecting the team's progress on things? No, not at all. We're just carrying on as we were. It hasn't made a huge dent in our funding. It did do there for a few days, but it's
just one moment. Just on the US side, everyone was paid this last pay cycle, and we had enough to cover everybody's bills. So, I mean, we're not dying, you know. I mean, we don't. It kind of had to be kind of like a bare bone, like, okay, well, what's everybody's bare bones? Because that's pretty much what we're operating at right now. But yeah, I mean, it hasn't slowed progress at all. We're continuing as usual, even during, you know, all the crap, you know, going down like last week. You know, I was just like, well, let's see what Tritium can really do, because it looks like the world's going to need it a hell of a lot more now than it did, you know, a few weeks ago. I mean, especially considering Ethereum imploding. So yeah, I mean, development's continuing just as usual, and the team is like we're all in it together, right? So I mean, I wouldn't expect to see like the team shrinking like any more than we already are. I mean, the most that kind of has to happen when we get into lower prices is some of us just have to take, you know, odd gigs and stuff like that, you know, to get some extra revenue coming in. But even then, like, there's enough interest with different use cases that, you know, we're working on also developing revenue streams in that regard as well. So, I mean, yeah, I just wanted to kind of drop that in, that, like, you know, we did have our last payroll last Friday and everyone, you know, got what they needed. So
yeah, taking the money side, some money out of it for a second, just in terms of the effects of COVID-19 on us. I think, like everyone around the world right now, we're locking ourselves away for the most part, and that means that we now have kids at home. For those of us on the dev team that have kids, we have kids at home. We're having to be a bit more flexible about our working hours, which, you know, I'm personally doing. You know, I'm going to be doing a bit more flexible hours, so I can look after my kids a bit more. But it's not really affecting the amount of work we're getting through or anything like that. We're still doing what we were previously. So no, I don't think it's really affecting us all that much, other than to perhaps give us a bit more drive, because I think we all realize that we need the kind of financial solutions, economic solutions that the blockchain can offer.
yeah, absolutely. And I mean, the team as it is right now, I mean, like I said, we're all in this together. So you know, I mean, when it comes down to, like, when the price is, you know, kind of low, like we've been kind of having to do it since, you know, it's lows, we just kind of have to take it as we take it, you know, once a month. It's just, okay, well, guys, this is what we got, and, you know, we divvy it up together. So it's actually been really cool. For me anyway, like, you know, kind of a silver lining on it is the team really kind of pulled together and was, you know, we all pitched in where we could to kind of make things work. So it's a good thing. I'm really grateful to be working with the team that we have. They're a good group of gents, and yeah, everybody's willing to do what we got to do to kind of continue keeping this thing going. So yeah.
Cool.
Any other questions?
No, that was all.
Cool.
What else? I think we're getting a bit long. We've been going for well over an hour. There was one other thing I wanted to talk about this week, but I think I'll leave it for next week.
Are we gonna do weekly or bi-weekly? I kind of like bi-weekly because it gives us.
Yeah, that's fine with me.
Yeah, so let's keep these at bi-weekly, unless you guys really want, you know, us to do them a little bit faster, more frequent. But we generally get more done when it's bi-weekly, because one of these, I mean, it takes like half an hour, at least 2 hours out of the day on Wednesdays to do these, so that's like 2 hours less coding. So bi-weekly is generally preferable for us if you guys don't object.
Yeah. Okay. Yeah. Okay. So next time I'm going to talk a little bit about the internal process changes that we have going on here in terms of our project planning and management, and how we can provide transparency to people on that. And we're going to start using GitHub issues and things like that, so people can have a bit more insight into what we're working on a daily or weekly basis, rather than just looking at our commits, and how we're using GitHub tools to plan our dev. So I won't go into all of that now. We'll talk about it a bit more next time.
Yep. Cool. Are there any other questions anybody has before we conclude?
That's all I've got from Telegram.
Nope, that's all.
Sorry, background noise. All right. Yeah, well, I guess I'll take my moment of silence from my neighbor and we shall conclude. All right, guys. Thank you.